Hi girls, so this video is about using quadratics to solve problems, and we'll just do this straight away by example. So there's a Y underlined there. So a rectangle has length 3 centimeters longer than width, and area 42 centimeters squared. Find the dimensions. Okay. Excuse me. So let's draw a rectangle, and it has a length and a width. So here's the width, here's the length, 3 centimeters longer, and we know that the area is 42. So now we've got an equation. So we know that the area is 42, and that is also width times length. And that is a quadratic, and we solve it, right? These things are not in any way complicated, I don't think, hopefully anyway. Minus the 42 across, use the man method. 42 is what, 6 times 7? Yeah, it doesn't work. I'm having a complete and utter brain freeze. How can it be anything else? It can't be, damn it. Bad numbers textbook. So to solve this we need to use the quadratic formula. So it's negative 3 plus or minus the square root of 9 plus 4 lots of 42 all over 2. And the important thing to note now is this plus or minus, right? So this W is the width of a rectangle. In other words, it is a dimension, it is something real, so it must be positive. So the only answer that we could have would be the one that is positive, right? Whatever that is divided by 2, and according to the textbook, the answer is 5.15 to 3 significant figures. Okay, so the important thing, the only real thing new here is that we just say that, well, because it's a length, it must be a positive length, and so we just effectively discard the other one. Right, I'm going to pause now, write out the question, and then answer, and then talk about it. Okay, so this question wants to know if it's possible to bend 12 centimeters of wire into a right angle triangle of area 20 centimeters squared, and in fact I only want the perpendicular sides. Okay, so what that means, I'm going to have to find a better way to write out these worded questions, because that's unwieldy at best. So what this means is, here's my right angle triangle. The wire is these two side lengths, and if this thing here is h, then this thing here must be 12 minus h, because the two sides must add to give 12, because it's a 12 centimeter wire. Okay, so let's do the area. So the area equals, I hope this wind isn't too noisy, it's quite pleasant sitting out here, I must say. So there's an expression for the area, and I'm actually going to stop there, because if you think about what this is, right, this is a quadratic where the axes are A and H, and it has roots at 0 and 12, and it's concave down. So it looks like this. So the biggest area occurs here at the vertex, and the vertex occurs right in the middle, 6. So let's calculate the area when h equals 6. So when h equals 6, the area equals 6 times 6, which is 36. Hold on a second. Area is half base times height. So area is half. I wonder how many of you had noticed that already. I'm guessing 11. So that's 18 centimeters squared. So what we've shown is that the area at most, because it's the vertex, is 18. So the answer is no. You cannot bend this triangle. Okay, I'm going to pause again and write one more question. Okay, so we've got two integers that differ by 12, and the sum of their squares is 74. So let's let the integers, integer means whole numbers, be x and y. So if they differ by 12, then that means x minus y is 12, and that's going to be equation 1. And the sum of their squares is 74. Okay, and we need to eliminate one of these variables. So let's eliminate x, just for the sake of picking something. So x equals 12 plus y. So therefore, 12 plus y all squared plus y squared is 74. So we get 2y squared plus 24y plus 144 is 74. We'll move the 74 across to make it minus 70, and we'll divide by 2. Sorry, I think I said minus 70, I meant plus 70. 35 is 7 and 5, which gives 12, yeah. So, pardon me while I make some room back up here. So I end up with y equals either minus 7 or minus 5, and then respectively x equals what, 5 and 7. And if you think about it a little bit, it makes sense that they are kind of positive negative pairs like that, and the numbers are the same. So this two here are a pair, and then the other two are also a pair. Alright, that's it for me for tonight. See you on Tuesday or Thursday, depending on who you are. Bye.